Hi guys, Mrs. Kohler here. Today we're going to do 6.2 representation of functions, so make sure you have your guided notes out for that. For example 1, this is writing function rules. So part A says write a function rule for the output is 5 less than the input. So when we do that, the output, if you remember correctly from way before all of our snow days, the output is our y value. Okay, like we did with those mapping diagrams. The word is just means equals. And then 5 less than the input. Remember, the input is your x value. So if we want to write 5 less than that, we would write y equals x minus 5. And that's all you have to do. You don't have to solve it or anything. So then for part B, same sort of idea. The output, meaning your y, is equals the square of the input. So if the input is x and we square that, we just give it an exponent of 2. So that's all you have to do for writing function rules. Like I said, pretty easy. You don't have to solve them. So that's how you do that. On the next one, let me switch slides here. So for example 2, this is also pretty simple. Definitely something that we've done before when you were in 7th grade, possibly even earlier than that. So when it says, what is the value of y equals 2x plus 5 when x equals negative 3? All you're going to do is take this x equals 3 and plug it in for your x right there. So you'll have y equals 2 times 3, and then you still have that plus 5. All right. Now, order of operations says that you have to multiply first. So y equals 6 plus 5, and then you can go ahead and add them. Y equals 11. All right, so like I said, you're just plugging it in, kind of like the substitution that we did last chapter. So go ahead and pause the video. You're going to work on the 4 on your own problems, and then unpause it to check your answers. So if you've worked out the on your own problems, number 1 says write a function rule for the output is 1/4 of the input. So there's 2 ways you can do this. Most people will do y equals 1/4 times x. All right, that's how you show 1/4 of the input. Another way that I've seen students do it, and again, this is just another option, both are correct, you could do y equals x over 4. All right, that also shows that the output is 1/4 of the input. So either of those is fine. The first one is probably more common. Number 2 says find the value of y when x equals 5. So if you plug in 5 for x, you should get y equals 19 for that one. Number 3, y equals 10x. So you should get y equals 50. And then number 4, when you plug in 5 for x, you have 7 minus 15, which is y equals negative 8. All right. Any questions on those? You can maybe ask someone next to you or shoot me an email, but those should be pretty doable for you. So, for example 3, we are going to be filling out an input and output table. And just by reading the question, we can get our input values. So, example 3 says graph the function y equals negative 2x plus 1 using inputs of negative 1, 0, 1, and 2. So you see those values there. Those are our inputs. We're going to put those in the very first column of our table. So go ahead and fill that in. Negative 1, 0, 1, and 2. All right. Now, When we plug those in, those values are going in for x just like we did on the last example. So we're going to have negative 2 times negative 1 plus 1, negative 2 times 0 plus 1, negative 2 times 1 plus 1, and negative 2 times 2 plus 1. So again, if you need a second to get that copied down onto your guided notes, go ahead and pause the video at any time. Now, the third column is the output column, or the y value column. So when we figure that out, we're kind of just calculating that column that we just wrote down with the negative 2x plus 1. So the first one, negative 2 times negative 1, that would give us a positive 2 plus 1 gives us a 3. All right. That then makes our ordered pair negative 1 from the first column, 3 from the third column. All right. The next output value, we would find that by doing negative 2 times 0, which is 0, plus 1 is 1, making our ordered pair 0 from the first column and 1 from that third column that we just figured out. All right. The next output is negative 2 times 1, which is negative 2, plus 1 gives us a negative 1, making our ordered pair 1, negative 1. And then the last output, negative 2 times 2 is negative 4, plus 1 is negative 3. So our ordered pair is 2, negative 3. All right, that is how you fill out the table. Now, right below the table, it says plot the ordered pairs and draw a line through the points. So our first ordered pair right here is negative 1, 3. So from the origin, we're going to go left 1, up 3, which puts us right about there on our coordinate plane. Then our second point, which is 0, 1, means you're going side to side 0 and up 1. My points might be a little bit off, but you can get the point, or the gist of it, I guess. The third point is at 1, negative 1. So from the origin, we're going to go right 1, down 1. And then the last point is 2, negative 3. So from the origin, you're going to go right 2, down 3, right about there. All right, and once you plot those ordered pairs, then you're just going to draw a line through them. Make sure you have arrows at each end of your line. And that is how you graph that function using an input-output table, finding ordered pairs, plotting the points, and drawing the line through it. All right, we have one more example. So example 4, I'm going to get you started on, and then you're going to kind of finish it up. All right, so example 4 says the number of pounds, represented by P, of carbon dioxide produced by a car is 20 times the number of gallons of gasoline, represented by G, used by the car. Write and graph a function that describes the relationship between gallons of gas used and pounds of carbon dioxide produced. So it says that the pounds produced is 20 times the number of gallons. So P is 20 times the number of gallons. All right, that's how we're going to get a function rule based on what the problem says. All right. I've also already filled that in to your input-output table right down there at the bottom. Now, your input typically it doesn't matter what numbers you use for your input. You can use anything. But in this case, you don't want to use any negative numbers because you can't have negative gallons of gasoline used. You're not going back into time or anything. So we want 0 or positive numbers. So you don't have to make it harder on yourself. I would just use 0, 1, 2. All right. Now, at this point, if you feel comfortable, I would pause the video and try and fill in the rest of that input-output table, just like we did on example 3. All right, now if you don't feel comfortable doing that, or if you've already filled it in, you're checking your answer, here's what your table should look like. So we are plugging these in for G. So P equals 20 times 0. P equals 20 times 1. And P equals 20 times 2. The equal sign looks weird. There we go. All right, that's how we fill in that second column. Now, our output, remember, is our p-value. So we're just going to multiply those numbers. 20 times 0 is 0. 20 times 1 is 20. And 20 times 2 is 40. Which kind of makes sense. So if you use no gallons of gasoline, your car is not going to give off any carbon dioxide. Makes sense, right? That's what that 0, 0 represents. The next one, if you use 1 gallon of gasoline, your car will give off 20 pounds of carbon dioxide. And then the last one, if you use 2 gallons of gasoline, your car will give off 40 pounds of carbon dioxide. So that's kind of how the real-life application of these functions work and why you would use them in real life. All right? So go ahead and work on the 6.2 page in your Chapter 6 assignment packet, and I will see you all soon.